the steps were, but there were not much proof of how the atom is. Okay, to study the detailed structure of the atom, another experiment was carried out, and that was alpha particle scattering experiment. In the last class, we just started with the alpha particle scattering experiment, right? So I told you what are alpha particles. So in the alpha particle scattering experiment, it was carried out by Rutherford and Giger and Mardison. So these were the two scientists who started with the alpha particle scattering experiment. They gave idea to J.J. Thomson that yes, we should study the alpha particles. We should perform an experiment. We can perform an experiment to study that or verify the structure of the atom that was proposed by J.J. Thomson. So here what they took a source of the alpha particles. So here some alpha particles source were kept, which was your bismuth. So bismuth was kept here as a source of alpha particle, and this from the bismuth, the alpha particles were allowed to cross a thin gold foil. Okay. So here some of the alpha particles in this path there were some a thin gold foil was placed. So here in front of this, a thin gold foil was placed over here, and the alpha particles they were allowed to pass through it. Yes. Yes. So in the alpha particle scattering experiment, basically here was a source of alpha particles. Something was kept over here. Suppose here was a source kept which was bismuth, and from this alpha particles were scattered out. So alpha particles they are represented like this, and the alpha particles, when I say alpha particle, so alpha particle it was helium nucleus. It was helium nucleus, and alpha particle was it has a mass of 4 AMU. Mass we had discussed, it has a mass of 4 AMU, and it has a charge of +2. It had a charge of +2. Okay. So the alpha particles they were allowed to pass through the gold foil, and here a detector was created. So a detector was made all around this. This was made up of zinc sulfide screen. So wherever the alpha particles will fall, it will produce scintillations over there. Now, since the alpha particles they traveled in a straight line, so it was expected that all the alpha particles they will be bounced back, right? Since the gold atom which is there, the gold foil which is kept, it is very thin. And if we assume this gold foil to be made up of J.J. Thomson's model of atom, just we assume that yes, it is the J.J. Thomson model. So whatever alpha particle was passing through it, suppose I take an alpha particle. So an alpha particle was passing through it like this, another alpha particle passing through it like this. So it was expected that all the alpha particles, they will be returning back. Okay, they will not be able to pass through the gold foil, right? Since the alpha particles are positively charged, and also atom is a sphere of positive charges, so it should not be able to penetrate the atom. Also we know that all the mass of the gold is too large, hence it should not be able to penetrate the gold atom. Okay, so it was expected that they will return, but something else was observed. It was observed that most of the alpha particles passed straight, undeviated. Most of the alpha particles passed straight. A few of the alpha particles deviated by small degrees. Only a few alpha particles they were deviated by small angles. Okay. And very few, about 1 in 8,000, returned back. Okay. So these were the three observations which were provided by the alpha particle scattering experiment. Okay. So Abhinav,
Sir,
can you recall the observations of the alpha particle scattering experiment?
uh, they are bouncing back. So,
Yeah.
I
What was?
just joined right now. I have internet
No,
issues.
you need not learn them. You just understand them. What all things are happening here? Okay.
Only
Yeah.
few bounced back, sir. Most of them penetrate.
Okay. Neha, are you trying to answer?
Yes, sir. So, like few
Okay.
of the alpha particles passes through the gold foil, and few of the alpha particles, like deflect from the uh, gold foil, and only like very few of the alpha particles rebound. So,
Okay. So not few, it's most of the alpha particles passed straight. Okay, most of the alpha particles passed straight. Okay. So this was one. And the second one was few alpha particles deviated by small angles. So few of the alpha particles they deviated by small angles. And the last observation was that about very few. So here it's very few. That's about 1 in 8,000. Very few particles. That is about 1 in 8,000. About 1 in 8,000 bounced back. So what indication does it give about the structure of the atom? Is that most of the space inside the atom is empty. So that is why the alpha particles they were able to pass through it straight. Okay. Since most of the space is empty, then only the alpha particles can pass. Otherwise, the alpha particles cannot pass through that. Okay. So it this model or the results of this experiment it was explained by E. Rutherford. So E. Rutherford he explained this experiment. According to the Rutherford, he considered the gold to be made up of atoms, something like this. He considered the gold foil to be made up of the atom, and the atom is such that most of the space inside the atom is empty. So he considered the atom. See, so as see, there are two visualizations. If we understand the Rutherford model, so according to Rutherford, the atoms were something like this. See, this was a Rutherford's visualization on the basis of which he had explained. So he said that the atom is a sphere of atom is spherical, but most of the space inside the atom is empty. Okay. So this is how Rutherford is explained. That atom is something like this. But if you consider the same thing for J.J. Thomson, so according to J.J. Thomson, atom was not something like this. According to J.J. Thomson, yesterday in the last class we had discussed, if we were discussing the J.J. Thomson model, so according to the J.J. Thomson model, the atom would be something like this. It is a sphere of positive charge, and hence the alpha particles could not penetrate it. So the model of Rutherford was something like this, that atom is spherical, but most of the space is empty. and within the atom there is a very small space where all the positive charge of the atom is located. So all the positive charge of the atom is located at the center. That is called as the nucleus. So we call them as conclusions of the alpha particle scattering experiment. Okay. Now, Siddhisri, can you tell me the conclusions of the alpha particle scattering experiment? What all conclusions did Rutherford made? Yeah, Siddhisri.
Sir, that most of the space inside the atom is empty.
Okay, so first conclusion is that most of the space inside the atom is empty. Uh, Siddhisri, are you
Yes,
not able to turn on? Why you are not speaking?
sir, it was my mic was not on in that time.
Okay, it was not owning or I was not able to turn on my mic. Okay, most of the space inside the atom is empty. So what was the second conclusion? What did the second conclusion he draw about the atom? Okay,
Sir,
Orosmith. Yeah, Orosmith.
yes,
What was the second conclusion?
electrons move around the
Hmm? See, most
electrons
of the
move around
space
the
inside the
nucleus
atom.
in circular.
See, almost all the mass of the atom is concentrated in a very small volume. So it is the second one that almost all mass and positive charges. Almost all mass and positive charge is concentrated at the center. Is concentrated at the center. Okay. So almost all mass and positive charge is concentrated at the center. This was the conclusion out of it. Okay, how he concluded? Since most of the alpha particles are passing straight, a few of them are bouncing back. So an alpha particle will bounce back only if the mass is heavy and it's very small. So most of the alpha particles, almost all mass and positive charge is concentrated at the center. This is the second point. Then third point we got here that electrons revolve around the nucleus. So these were the 3 points are drawn from this Rutherford model. Electrons revolve around the nucleus. So they are massless. The complete mass of the atom is concentrated at the center. So at the center they have a mass, and outside the center there is no mass. Okay. So understood these conclusions?
Yes, sir.
Okay. Now he put forward on the basis of these conclusions, he put forward the nuclear model of the atom. And according to the nuclear model of the atom, this almost all first point is that almost all the mass of the atom is concentrated at the center within the nucleus. Okay. And the nucleus is positively charged. All the protons and neutrons, they are concentrated within the nucleus. And the negative charges or the electrons, they revolve around the nucleus. They just revolve around the nucleus. So, since Rutherford made out his alpha particle scattering experiment and all the results they were explained on the basis of this, so he was the one who used here the nucleus. So that is why his model is also called as nuclear model of it. He also termed his model as nuclear model. This model is also called nuclear model of the atom, where there is a new centralized nucleus within the atom. Okay. So understood? Who proposed the nuclear model of the atom?
Rutherford.
Rutherford. Okay. So according to Rutherford, where are electrons?
They revolve around
The nucleus.
They revolve around the nucleus. And where is the positive charge?
Center.
At the center.
In
In the nucleus. So within the nucleus, all the mass of the atom is concentrated, and hence most of the space inside the atom is empty. Okay. So now this was quite clear. Everything was understood. There was just one major problem with this model. Okay. And the major problem was that he said that electrons revolve around the nucleus just like the planets are revolving around the sun. So he assumed them to be similar to the planets. That just like the planets are revolving around the sun, since the planets, they are attracted towards the sun by gravitational force of the sun, right? So here also there are some forces, and those are the electrostatic forces. So this is the nucleus, and outside the nucleus the electrons are revolving. So here the electrons which are there, the electrons are held by the nucleus. They are held by the nucleus with the electrostatic forces of attraction. Okay. Now, what was the problem over here? He was very thoughtful. The things were good. That yes, it can be similar to the planets, since planets are also revolving around the sun. So, in the similar way here, the nucleus is, the electrons are also revolving around the nucleus, and there is also a force of attraction. That is the electrostatic forces between the nucleus and the electrons. Now, the problem was that the electrons are not similar to planets. The electrons are quite different from the planets. And the difference is that electrons are charged objects. So electrons are charged, charged objects. They have charges, whereas planets do not carry any charge. Do planets have any charge?
No, sir.
No, planets do not carry any charge, but there is a charge on the electron and proton. So, because of this, if the electrons revolve around the nucleus, so this will be an accelerated motion. Okay, so this will be an accelerated motion of the electrons, and if the electrons are revolving around the nucleus, so they must radiate energy. Okay, electrons must give out energy when they are revolving around the nucleus. So this is an accelerated motion. An accelerated motion of electrons will give out energy. Accelerated motion of charges radiates energy or give out energy. So if the electrons radiate energy, if the electrons are giving out energy, so hence the orbit of the electron will change. Okay. And if their orbit changes, so their orbit will become something like this. Their orbit will become something spiral. It will not remain circular. Their orbit will become spiral, and the electrons will enter the nucleus. And if the electrons enter the nucleus, it will be the same model of J.J. Thomson which J.J. Thomson had proposed. So the problem with this model was that Rutherford could not explain the stability of the atom, how the atom is stable. If the atom is stable in this situation, if the electrons are revolving around the nucleus, so how they are stable in their orbits? How they are not moving into the nucleus?
They don't radiate energy.
So why they don't radiate energy? Why are not they radiating energy? Since it is an accelerated motion, so why they are not radiating energy?
Orbits, they're like discrete.
How can you say that orbits are discrete then? Okay. So this problem was resolved by Niels Bohr. Okay. So understood. This is the main drawback of the. You can say this is the main. We call it as the drawback of the model. So what is the drawback? It could not explain stability of atom. It could not explain stability of atom. If the atom is established like this, so how it is stable, this was not explained. So who explained this? It was based on it. It was explained by Niels Bohr. So it was explained by Niels Bohr. So how did Niels Bohr explain this? How he was able to explain this? And someone had answered this. Who had answered that?
It was me, sir.
Okay. So you are correct up to your knowledge. So up to your knowledge, the thing is in whatever you have been taught that yes, what Niels Bohr said. Niels Bohr said that electrons revolve in discrete orbits. Like, so electrons revolve in discrete orbits. Discrete orbits means there are certain orbits of stable energy. Near the nucleus, there are certain possible orbits where the energy is stable, where the electron can revolve without radiating energy. Okay, so there are certain possible orbits where the electron can revolve without radiating energy. Okay, so electrons are revolving in those discrete orbits, and there is a capacity of each orbit. It's not that any number of electrons can orbit anywhere around the nucleus. There is a fixed orbit only where you can find an electron. Okay, so if you it is something like this. See, he stated that suppose if this is your nucleus, okay, if you consider this to be your nucleus and let electrons revolve around this. So suppose I am considering here two orbits. Let's have there are the two orbits around the nucleus. So as per Niels Bohr, he said that you will be able to find an electron in this orbit. Okay, here only in the orbit. You cannot find any electron out of the orbit. This electron cannot move out of the orbit at any time.
And sir, that orbit can only have two electrons according
Yeah,
to two
and
experiments.
he calculated and showed that he calculated and formulated that what should be the maximum capacity of each orbit. Okay, so now even if you try to find out, can I find an electron over here? So the answer is no. You cannot find an electron over here. Electron will always be found in its orbit. Okay, if you want this electron to find in between, it's not possible. Electron will orbit only in its orbit. Electron will be revolving only in its orbit, and till the electron is revolving in its orbit, it cannot radiate energy, as these are orbits of stable energy. Okay, so electrons revolve in discrete orbits or shells. They do not radiate energy.
So the shells are like K, L, M, N, right?
Yeah, they do not radiate energy. Radiate energy when in their orbits. So when they are in their orbits, they will not be radiating any amount of energy. So electron, so this is your first orbit, then you have the second orbit. Similarly, you will have your third orbit, then you will have fourth orbit. So in this way, there were a number of orbits which are possible. Okay. The first orbit, it was called as the K shell. Second orbit was called as the L shell. Then third orbit was called M shell. Fourth orbit was called N, and so on. Okay, so these were the names of the orbit. You can call them as 1, 2, 3, and 4. So these are the shell numbers, or orbit number 1, orbit number 2, orbit number 3, and orbit number 4. You have orbit number 5, you have orbit number 6, you have orbit number 7. Okay. Now there is a capacity of each orbit, and the capacity of each orbit is given by the formula 2n squared. Capacity is given by the formula 2n squared, where n is the number of the orbit. Okay. So using this formula, if I want to find what is the number of electrons that can be accommodated in this first shell, so it will be 2 multiply 1 squared, which will be equal to 2. The second one will be 2 multiplied 2 squared, it will be equal to 8. The third one will be 2 multiply 3 squared, this will be equal to 18. Okay. Similarly, 2 multiply 4 squared, so that would be 32. So your first shell will hold an electron equal to 2. Second shell can hold a maximum of 8 electrons. Third can hold a maximum of 18. And fourth can hold an electrons equals to 32. Okay. So Aman, how many electrons will be held by the fifth shell?
Which shell?
Fifth shell will be holding how many electrons?
Sir, is it 50?
50. Okay. Fifth shell will hold 50 electrons. So in this way, he calculated and told that how many electrons are possible in each of the orbit. So if these electrons are revolving in the second shell, they will not be radiating energy. Also, if an electron has to move from first shell to second shell, okay, so it needs some amount of energy. It needs to absorb energy to move from first shell to the second shell or to the third shell. So the electron requires an energy to jump the orbits. Okay, and similarly, if the electron jumps from outer orbit to the inner orbit, it will radiate energy. It will give out energy.
Sir,
Yes.
sir, if the third shell can have 18 electrons, then why do we write the electronic configuration like 2, 8, 8? Why not 18?
Over there, we follow the octet rule. Okay. So I'll just tell you about the octet rule once we start writing about the electronic configuration. Okay.
Yes,
So
sir.
everyone has, okay, so everyone has understood this? Any doubts? Siddharth, any doubts?
No, sir.
No. Siddharth is a good boy. Okay. Rikshit? Rikshit?
Yes, sir.
I can still find Rikshit, Harini,
Sir,
Neha, all
hello.
your,
Can you hear me?
yeah, I can
Yeah.
find all your cameras off.
Sir, my camera isn't working. It's giving a black screen.
Okay.
I'll fix it, sir. I joined the class. This is the first class I joined after my exam.
Hmm. So everyone, Harini, all the cameras should be on. Everyone's camera should be on during the class. So I think this is clear to everyone. We were trying to explain the structure of the atom. So Niels Bohr, he tried to explain the structure of the atom. So it was correct that the protons and neutrons, they are situated within the nucleus. Okay. Protons and neutrons, they are situated within the nucleus, and electrons are revolving around the nucleus in circular orbits. But there are certain fixed orbits in which if the electron revolves, it would not radiate energy. If the electron moves out of those orbits, so the electrons will be radiating energy. Now see. So now he also explained the arrangement of electrons, how the electrons are arranged. As we just saw that K, L, M and N, these are the orbits around the nucleus. So the K orbit or K1 is the first orbit. It is the innermost shell. After that you have L, then M and then N. So in this way, these are the possible orbits. Now out of these, if I tell you which orbit has the least energy. So which orbit has the least energy out of these?
The furthermost, like the last one.
Last one. Okay. Anyone else? See, this K shell has the least energy. Okay. This is the least energy, then a greater energy, then a greater energy, and then a greater energy.
So, but then the closest one will have more energy as they're very close and they're
The
very
closest one has the least energy. Okay. So learn the closest one has the least energy. And second thing, we talk of the stability. If anything is stable, so it is always stable in the form of lowest energy. Lowest energy is the stable configuration. So that is why when the electrons will be arranged, so they will be first filling out the K shell, and once the K shell is filled up, then they will be filling out the L shell, then they will be filling out the M, and then N. So in this way, your orbits will be filled. Why they are filled like this? Because of energy. Understood? Why the K orbit is filled first? Why can't the L orbit be filled first? So why can't we fill the L orbit first and then fill the K shell? It's because of the energy. K shell has the less energy, and therefore K shell will be filled first. Okay. So okay, that's it. The K shell, it can accommodate 2 electrons. So we will be writing the electronic configuration of the elements starting with hydrogen. So I'm starting with the elements from hydrogen. That is atomic number 1. So here I write atomic number, and here we write the symbol of the element. So atomic number 1, that is your hydrogen. So the number of electrons will also be equal to the atomic number, which is the number of protons. Right? Number of protons and number of electrons, they will be equal. And hence there is just one electron which will occupy the K shell. Then you have the helium. It has atomic number 2. So it will, the 2 electrons are there which will occupy the K shell only. Now the K shell is complete. So if you ask for lithium, which has atomic number 3, so it will have a configuration of 2 electrons will be first filled in the K shell and 1 electron will be filled in the L shell. Okay. So can you write in this way? Can you write for carbon? What will be the configuration for carbon? For me, all of you write down the electronic configuration of carbon, whose atomic number is 6, oxygen, atomic number 8, fluorine, atomic number 9, chlorine, atomic number 20, atomic number 17, aluminium, atomic number 13, and potassium. Okay, potassium will I'll tell you. Potassium is 19, but before that, let's do sodium. That's 11. Okay. So start writing the electronic configurations. Okay, Pranay given the answer for carbon.
The number of electrons will be the same as their atomic number, right?
Yeah, atomic number means the number of protons.
Yeah, but no, it will be same only. The number
Yeah,
of electrons.
it will be the same. Atomic number is the number of protons. Okay. And in a neutral atom, if the atom is neutral, so the number of protons will be equal to the number of electrons.
And we can also represent it as V equals P equals V.
Okay, once you are able to write all this, then you have to write the electronic configuration of this Mg2 plus and Cl minus 1. You have to write their configuration also. Mg2 plus and Cl minus 1.
Sir, isn't Cl and Cl minus 1 like the electronic configuration gonna be the same?
For which one?
Cl and Cl minus 1.
No, they won't be same. Do they have the same number of electrons?
No.
Cl minus 1 and Cl, do they have same number of electrons?
Oh, okay, no, sir.
No.
Okay.
So they can't have the same configuration. Okay, so I'm receiving some of the answers. I received answer from Harini and Pranaya. Okay. Siddharth also gave the answer only for carbon and oxygen. And fluorine.
Sir, I'm just typing the answer one sec.
Okay. Okay. So let's see who all has given the answers now. No one else has given right now.
Sir, I just sent the
Aman,
answer.
yeah, Aman has sent for carbon, oxygen, fluorine, aluminium, Okay, Siddharth has also sent for aluminium. Very few of you have sent me the configuration of Mg2 plus and Cl minus 1. Chavan Kaushik, you are not giving any of the answers. I am not getting.
Sir, I'm doing MGCL1. I don't know if it's correct, so I'm redoing it.
You don't know for which one?
MGCL1, sir.
Mg2 plus and Cl minus.
Yes, sir.
Okay. And still, let me see who all have not given the answers. Orosmith, are you not able to get the answer? Orosmith, Neha, and Rikshit. You are not providing any answers. Siddhisri, you are also not giving any answer. I'm not getting.
Sir, even I'm not able to get answers.
Sir, can you explain?
Yeah, so that is what you should be able to ask. You should be asking to see how we obtain the electronic configuration of each element. Suppose I'm writing the electronic configuration of carbon. Carbon has atomic number 6. Okay. See, atomic number 6, it means,
Sir,
yeah,
I sent Mg plus 2. Can you check if it's correct?
no, it's incorrect. Siddha, who is, okay, Aman. No, it's incorrect.
Right to send it.
Yeah, Siddharth has sent, that's also incorrect. Okay, just I'm explaining here. See, if I write carbon 6, so it means there are 6. It means its atomic number. I will write its atomic number, which is same as the number of protons. So atomic number will be same as the number of proton, and it will be same as the number of electrons in a neutral atom. If the atom is neutral, so it will have the same number of electrons. And then I will write the configuration. So at the end, yeah,
Sir, I sent it now. Is it correct now?
okay, just wait.
So even I sent.
Chavan Kaushik, no, Chavan, it's incorrect. Harini, it's incorrect. We just pay attention now. Siddharth, it's correct. Siddharth has sent, that one is correct. Okay, see. See, if carbon, we write here 6, so it means that the carbon has atomic number 6. There are 6 protons and there are 6 electrons in the neutral atom. And they will be arranged at 2 in the K shell, and L, you can write K, L, M, and N. So K shell will have 2 electrons and L shell will have the remaining 4 electrons. Rikshit, are you getting?
Sir, but L can hold up to 8 electrons.
Yes, sir.
Yeah. Yeah, Chavan Kaushik, why are you ask? What is your question?
L shell can hold up to 8 electrons, so why does it
It-
need to take all 8?
Because there are only 6 electrons.
Oh, okay. So it's just
There are only 6 electrons, and first the K shell will be filled up. Okay. So K shell will hold, it can hold a maximum of 2 electrons only. Okay. Assume that if you are going to a show, so you try to occupy the first seat, right? So in the similar way, here also the electrons will first occupy the K shell. Now, if any electron is left, so it will occupy the L shell. Now, if the L shell is fulfilled, so it will occupy the M shell. So in this way. Okay. So after carbon, I gave you oxygen. Atomic number is 8. So it will have 8 protons and there are 8 electrons in the neutral atom, right? So there are 8 electrons in the neutral atom and hence they will be arranged like 2, 6. 2 in the K shell and 6 in the L shell. Neha, are you able to understand?
Yes, sir.
Okay. Rikshit? Rikshit?
So what's the maximum for L again?
Yeah, maximum for L is 8. Okay. When the 8 electrons will be filled in the L shell, then it will be filling the M shell.
Sir, can we do for Amjad 2 plus?
For, okay, just I am doing. Now, if you write for fluorine, just write for fluorine, aluminium, sodium. So for fluorine, atomic number is 9. So there are 9, atomic number 9. There are 9 protons and there are 9 electrons. So they will be arranged 2 in the K shell and 7 in the L shell. If you add them, you see you are getting 9. Okay. Rikshit, can you tell me the arrangement in sodium, which is atomic number 11?
281.
281, right. So it would be 2, 8 and 1. Okay. For aluminium,
2, 8.
3.
2, 8 and 3. If you add, you are getting 13, which is the atomic number of aluminium. For chlorine, its atomic number is 17.
7.
2,
So you should
8. Sorry. 2, 8, 8, 1.
287.
Yes, sir.
Okay. For Cl minus 1, chloride Cl minus 1. Now we want to find out the configuration. See, the chlorine itself has 17 electrons, right?
Yes, sir.
So chlorine itself has 17 electrons and minus 1 means chlorine has an extra 1 electron.
Okay.
So chlorine will have a total of 18 electrons now. This is 17 plus 1. Are you getting? Chlorine will have 17 plus 1, that's 18 electrons. Okay, this chloride ion or Cl minus 1, it has a total 18 electrons and hence the occupancy will be like this 2, 8, 8. Understood?
Yes.
Okay. In the similar way, if I write for Mg2 plus,
2,
so
8.
Mg2 plus, Mg has an atomic number of 12. So there are 12 atomic number, 12 protons, but the number of electrons which will be there, the
2,
number of
5.
electrons, it is showing a charge of +2. That means 2 electrons have been removed out of it. Okay.
2, 8.
Yeah. Just let me ask someone. Orosmith,
Yes, sir.
how many electrons are there in Mg2 plus? Okay, how
Sir,
many
can you have,
electrons?
sir, can you
How
ask
many
one?
how many electrons are there in Mg2 plus?
Uh, 10.
10. How you get 10? How you get 10? See, Mg has a total of 12 electrons, right? Magnesium has a total of 12 electrons and it shows a charge of +2. A charge of +2 means 2 electrons have been removed out of 12. So it will have a total charge, total electrons of 12 minus 2. That will be equal to 10 electrons only. Okay. So it will have a configuration of 2, 8 only, not 2, 8, 2. Okay. So your homework, as your homework, you will be doing.
Sir, but its
You'll be
atomic number is 12, right?
yeah.
Magnesium's atomic number is 12, so it has to sum up to 12.
Yeah, magnesium atomic number is 12, but the electrons can be given out or they can be taken in. Okay. So if I write as Mg2 plus, so Mg2 plus, it means something like this. Mg2 plus, it means something like this, that it was earlier magnesium, and this magnesium, it becomes Mg2 plus by giving out 2 electrons. It has donated 2 electrons.
So it's just 2 comma 8.
Yeah, so 2 electrons have been removed out of it, and hence
So
it
it's
has
just 2 comma 8.
just 2,8 only. Okay. So as your homework, you will be doing you will be just writing down electronic configuration of Al3 plus, potassium, K plus, calcium, and Ca2 plus. So these are your homework. Only these are for your homework. Kindly note it down. Al3 plus, potassium plus, Ca and Ca2 plus. These are for your homework. Also this one, O minus 2, oxide ion also. Okay. Bye everyone.
Bye, sir.
Okay, good night.
Bye, sir. Thank you, sir.
Okay, bye. Hmm. Yeah.